Good morning, everyone. My name is Chris Modrich. I'm the valve product specialist for Lessman. I'd like to thank you all for taking the time out of your busy schedule to join us this morning. For our webinar, we're calling Best Practices in Applying Safety Relief Valves in Hygienic Applications. In this session, Megan Sider-Elm of the Steriflow division of Rupture Industrials, which is right out of Cincinnati, Ohio, will cover the why and when you need overprotection, options for pressure protection, rupture disc versus sanitary relief valves, the function and design of sanitary safety relief valves, safety relief valves maintenance and best practices, and at the end we'll do a little ask the expert if you have any questions. And we're going to have a pretty dainty group on this initial one here, so if anybody has any questions, you can pretty much speak up sort of as we go here. So Megan joined Richards Industrials as a global product manager for sanitary products in 2021, and her job is to focus on the stainless steel market space, which is going to be, food, pharmaceutical, food and bev, etc. Prior to that, she served as a product manager and application engineer for valves in the specialty chemical, refining, petrochemical industries. She holds a bachelor's degree in chemical engineering from the University of Pittsburgh, and is an all-around excellent helper on all this stuff. So with all that said, Megan, I'm going to turn it over to you. You can flip your own slides at your own pace. Have at it.
Great, thank you, Chris. And yes, thank you guys all for joining. So with that, we'll go ahead and get started. As Chris said, we're here to talk about SSRVs, or sanitary safety relief valves. You might also see the acronym PRVs for pressure relief valves, or SRVs for safety relief valves, with the really core piece of this just being pressure protection, and as it focuses on the safety side of things. So why is pressure protection needed? It sounds simple enough, but here are some real examples of what happens when you don't have efficient pressure protection. Now, in the pharmaceutical market, in the food and beverage market, these vessels tend to be a little bit smaller, but the ultimate concerns remain the same. If you have a pressure vessel, a pressure containing vessel, there is always that risk for a runaway reaction, a upset condition, which can lead to an overpressurization, which can cause catastrophic disasters. When you look at it at the biopharma or food and beverage side, you also have the issue for an overpressure situation causing damage to the actual products. So safety is the key focus here, and how do you protect the system when upsets happen? So ASME is the name in certifying or laying out standards for these overpressure protection pieces of equipment. ASME is the name in the market. They have, most people understand Section 8 is the regulatory standard for all unfired pressure vessels. Now, ASME has recently released a new revision of this standard where they combined a lot of other standards, and it's now ASME Section 13. So if you go through and are hearing different standards, ASME Section 13 is the most recently released overpressure protection standard from the ASME code. However, a lot of people will still refer to ASME Section 8 as it has been the standard in the market for the past several decades. ASME boiler pressure vessel code is basically in charge of setting regulations for all pressure vessels, for unfired vessels, for anything over 15 psi. If you have equipment or vessels that are below 15 psi, because of the low pressure nature of that system, the ASME code does not apply. Anything over 15 psi will require some sort of pressure protection equipment. And this can either be a rupture disc or an SSRV. But these are highly regulated pieces of equipment that have gone through strenuous testing, design reviews, audits, and all being conducted by the national board. So if ASME Section 13 is the code and the rules for pressure systems, then the national board is that enforcement arm. Any pressure relief equipment has to be rigorously tested and audited by that national board, and any manufacturer, repair, or testing body that is able to touch these valves or rupture discs needs to require a stamp from the national board saying that it passed all of these requirements. So the UV mark is the stamp is the official certification mark that designates pressure relief valves, and NB, or national board, is the stamp that signifies that the national board has come and given the stamp to the local manufacturer or repair house. So you can see an example of what those stamps look like on the right-hand side of your screen. Any relief valve will have these stamps on the tag, and it is a requirement that these are stamped just as you see on the tag to show that they do meet the ASME Section 13 code. So kind of going into your options when you look at how do you protect against pressure. So if you have a ASME Section 13 pressure vessel or system, you need to have a protection. So one of the most common ways to do that is by a rupture disc. Now, rupture discs are exactly what they sound like. It is a very thin piece of metal that is scored in just a way it will burst at a predetermined pressure. These rupture discs are highly, highly engineered for such a simple piece of equipment because they need to rupture exactly at that point of the system in order to protect it from either failure of the system, failure of the vessel, or protection of the product inside. So every time you buy or require a rupture disc, you typically have to buy at least three actual rupture discs. And what happens is once you purchase a rupture disc, the company that you're purchasing from will take 2 of those rupture discs and actually burst them. So every time you get these rupture discs, they are testing as they go to make sure they burst exactly at that pressure. So some of the benefits of having a rupture disc is they're usually much more cost efficient than a sanitary safety relief valve, and they have a smaller footprint. So you do see these a lot in small pieces of equipment, small breweries, small food and beverage plants, because they are just easy. Some of the cons that you have with them is they are single use. Every time you have an overpressure a situation and a rupture disc goes off, it needs to be replaced. They are also very fragile. So because they're such a thin piece of metal and they have to burst no matter what at that set pressure, they are very, very fragile and they can be susceptible to bursting prematurely. A very common reason for this is if a rupture disc is within the piping system, any pipe has a certain level of pipe strain. And if you have a long run of pipe with a very drop in elevation or not properly supported, that pipe strain can then put extra pressure on the rupture disc and cause it to burst prematurely. And then finally, especially in the sanitary world, especially with biopharma applications, but also food and beverage applications as well, if you have a rupture disc on a vessel or on a separation like a chromatography skid and it bursts, you can expose all of your product to atmosphere, because the only way a rupture disc can relieve pressure is if it bursts to atmosphere. So if that happens, then all of that atmosphere is now in contact with the final product and will cause you to scrap the entire batch. It's a significant pain point in the biopharma industry because those batches become very expensive. And if you have inherent pipe strain or you have rupture discs that tend to go off a little early and you are wasting batch after batch, it can be a very high pain point. So the other option would be a sanitary relief valve. So these work very much in the same way as a back pressure regulator. So these valves are normally closed until that pressure reaches that set point of that valve. So when that happens, the valve will lift off its seat slightly to relieve any pressure that's in the system. Some of the pros to this valve is it is reusable, so it can reseat. If there is an upset condition and the valve opens or pops, then once the pressure dissipates, then the valve will reseat and you can continue running your process. They are completely compatible with any CIP or SIP process, and we'll get into that in a few slides of how you would do that. But if you need to clean your process, these valves are very easily cleanable. They are also very resistant to premature release. So like I said, with pipe strain, because the valve is contained with, or the pressure relief actuation is contained within the valve body, it is much more robust compared when you consider pipe strain. So if you have a part of your system that has a lot of pipe strain in it, a relief valve is a good option to resist against that. And probably the number one benefit to this is it can keep the process sterile. So if there is an upset condition, you can pipe off the relief into a sterile holding tank or sterile pipe work and be able to continue running your process rather than scrapping those batches. So in the biopharma industry, where batches are very expensive and you want to keep that product, it becomes a very significant benefit. There are always cons to any product, and one of the cons is, it is a higher upfront cost than a rupture disc because it is a full working valve. And then it also does have a larger footprint. As these biopharma vessels are getting smaller and smaller, it's sometimes hard to fit a working valve into that process. However, there are ways to mitigate that, and I'll go into that in the upcoming slides. So with that, we're going to move into why safety relief valves are a really great choice for the biopharma market. So pressure relief is needed in many different points of use for a biopharma industry. So any vessel, even on single-use vessels, they will still need that pressure relief. Glass vessels especially, because glass vessels need a very stringent pressure requirement, or the glass can break much easier than a stainless steel vessel. Any skids for separation, so all chromatography columns or chromatography skids typically have at least one sanitary safety relief valve. And then on clean steam, so clean steam can be applied both to biopharma industries and food and beverage. Anytime you need that pure steam, you need a sanitary relief valve. And then last common practice or common application would be lyophilizers. So when you're pulling a vacuum to dry out your final end product, lyophilizers will typically include a sanitary safety relief valve. So what makes them sanitary? Why are they different from an industrial safety relief valve? So with the sanitary market, just very similar to what you would see in the food and beverage or the biopharma specifications, all wetted parts are made from 316 steel, and all soft polymers, molded plugs or bellows are a USP Class 6 and FDA EPDM material. EPDM is the most common material because it works very well against steam, and it's very flexible to work well over time. All internal surfaces are finished to 20 RA or better. External surfaces are 40 RA or better, and these can be adjusted, and we can get to lower surface finishes if required as well. So that internal surface finish is very important for keeping that process sterile as it flows through the valve. Like I said, all soft materials are USP Class 6, and these are designed to use in pharmaceutical applications to keep the process sterile. Non-sanitary safety relief valves are used in various points as well, but the reason sanitary becomes so important is when they are on process media or anything going into the drug production. So valve terminology, so everybody is aware of it. The relief valve industry does have its relief valve speak, if you will. There's a lot of jargon that goes into this industry. And some of the things that you might come across when talking about safety relief valves, first audible is how the set point is defined on steam. So these valves are tested both on steam and liquid, or steam, air, and gas, or liquid is the two designations. In terms of the gas set point, so that it can be air, steam, or gas, first audible is that set point. So most people think that when the safety relief valve gets to its set point, you'll hear that pop that is typically associated with that. However, that set point is just that first audible. So as soon as you hear pressure being relieved, and it basically just sounds like a stream of air or a slight whistle, that is that set point. And to get to a full pop, so a full open release, that's usually about a PSI or two higher depending on the set pressure. And that helps keep the process sanitary so it can relieve a little bit of pressure without fully going open, and then and reseat much faster. For liquid, the set point is steady stream. So again, as soon as you start seeing a steady stream of liquid flowing out of that valve, that is the set point. All of these valves are fixed blowdown. So fixed blowdown is just the point that the pressure that the valve will reseat. So if a valve is set to 20 psi and it fully pops, the pressure will have to decrease to at some point below that set pressure. So it may be 16, maybe 15 psi below that 20 psi set point in order to fully reseat and seal off. So fixed blowdown is something that is a designation for a type of safety relief valve, and being that all these sanitary safety relief valves reseat, they are all fixed blowdown valves. A lot of industrial valves that are not fixed blowdown, once they go off at all, they will immediately need to be repaired. That is not the case with a fixed blowdown valve. They are able to reseat and keep the process running. And lifting device. So this is a device that is able to open the valve to about 75% of the set point. And this is used for multiple things. It is required for the ASME code for any valve with a media temperature higher than 140 degrees, but also provides a lot of benefit in the industry as well for cleaning the valve and running CIP, SIP through it, and being able to open the valve without adjusting the set point. So each model is tested and approved by the national board for both medias. So as these valves get designed, the national board comes in, audits the design, and then tests every individual configuration on both air and water. And once these valves pass the very rigorous testing of the national board awards the stamp, which certifies that these valves will work per the specifications required. Just a note for everyone to be aware of on the call, no pressure relief device may be sold outside of the testing scope. So unless the pressure is below 15 psi. If you remember in the beginning of the call, ASME does not care about anything below 15 psi, which is just above atmospheric pressure. There are many applications where 15 psi or lower is used in the industry. And when I said, especially in biopharma, it's not just about the safety of the system or the protection against a catastrophe, right? It's also about the product in that system. So there are many applications where a safety relief valve will need to be set at 9 psi or lower. And we still have the capability of doing that, but just note it's not a national board certified valve at that point. It is just a standard relief valve. I'll kind of go into different configurations and different models that we do offer. So the first one, these are our smallest valves, the 81 and 81B. These are anywhere from 1/2 inch to 1 inch. So when looking at footprints of overall biopharma plants, these small valves are becoming more and more common just for a lot of the pros that I said at the beginning of the call. They are able to reseat and continuously run, so you don't have to stop for maintenance after every upset condition. And how you mitigate the footprint of these is we have the smallest ASME certified safety relief valve on the market at 1/2 inch inlet by 1/2 inch outlet. And they also are fully capable of being installed in the horizontal position. So if you do need to work around pipe work and stuff like that, being able to install these horizontally with the inlet either facing parallel to the ground or towards the ground, these valves will still work as they are expected to. These have two configurations, one with an O-ring seal for very high pressures and one with a standard molded plug for your more sanitary applications for the lower pressures that you're more typically going to encounter. The next size up would be our 83X. These are 1-inch inlets by 1.5-inch outlets. And these are going to be, so both the 83 and the 83X are your slightly bigger valves. These are going to be the primary process valves used in biopharma market. So anywhere from 1-inch to 2-inch, that's going to be your, like I said, primary process used on actual production of the drugs. The 81 and 81V are going to be typically seen on your separation equipment or very, very small vessels. The next sizes are our 88 series, so 88-1, 2, and 3. These are our big guys, if you will. They have the highest capacity. They have they go up from 1.5-inch inlet all the way to 2-inch inlet, 3-inch outlet. These are used on steam in the biopharma industry, but where you see these a lot is in the food and beverage industry, where there are much bigger volumes for different vessels in the food and beverage industry. So typically steam is the most common here. And just a note for everyone on the call, EPDM is the preferred material in steam. A lot of people want to try and specify Viton, but Viton in steam conditions tends to break down. So just as a note as you go through, EPDM is a much better choice in steam applications. So just quickly to talk on lifting devices. So the code does require lifting devices on all media that's over a certain temperature, which I said earlier. But if you're wondering in the biopharma market, how do you really clean these valves? You do it based off with a lifting device. So you run the process as you do. And once you need to clean it, whether it be CIP or SIP, you take the lifting knob and you screw it all the way down until it stops, and it pulls the plug off the seat. So then you can run the CIP and SIP through your system just as you would normally, and then close the lifting knob back up. So screw it back up until it stops. This reseats the valve. It does not affect the set point. So the set point is consistent throughout the life of the valve. If the set point ever needs to be changed, it needs to go to a national board certified repair center. So if you are wondering how you can make sure, people open and close it all the way, rather than, just depending solely on an operator to open and close that valve, we also offer a pneumatic lift device, which is exactly how it sounds. It's effectively automating that lifting with a controller. So you're able to lift the valve or the plug off the seat from a control room, clean the valve, and then close it again. With that, a very common addition to that is having a lift indicator or a proximity switch that will send a signal to the control room that says this valve did lift. And that can work with the pneumatic lift, and it can also work separately and send a signal every time there is an upset condition, letting you know that the valve was lifted, which can then indicate, hey, you need to clean this valve. So in terms of sizing, sizing of the SSRV or sanitary safety relief valve, we are able to size up to 100% capacity. We can size to very low capacities as well. However, we do require that our engineering team confirms and looks at all of that sizing and gives the okay. One thing for everyone to be aware of on the call is back pressure is a very common question as it relates to relief valves in general. But as these are fixed blowdown valves, back pressure is limited per the standard to 10% of the set pressure. Anything higher than that, and the pipe work will need adjusted in the plant. And that is per ASME code. That is not something that steroflow determined, but it's just something to be very aware of because that question does come up a lot. And as you go through, these are safety systems. They're highly regulated. They are always audited. It's very important that everyone understands the end user must be responsible for the actual sizing, selection of, understanding the flow rates, the back pressure, all of that, because a representative or even us as a manufacturer cannot know all of the ins and outs of every plant. So it's very important that all this information comes in so we can size these valves effectively to the system and give you what you need. We cannot, unfortunately, go do an audit of the entire plant. It is very important that we get this information to make sure we provide the correct valve for the application. So, and this kind of goes into this flow rate calculations, set pressure calculations, and then the determination of back pressure all needs to be determined before coming and giving us a option to quote. So some of the things that are very typical is the increase in back pressure and questions about back pressure. But like I said, per code, you want the back pressure needs to be no more than 10% of the set pressure. We don't recommend the use of multiple valves on a single vessel. It does affect the overall capacity needed. However, that is a determination that the client will make, and we can only we can size per the situation given to us. So setting and testing, these valves must lift at a certain set pressure, and this is very common testing method for the national board. So if you have any questions about how these valves are tested or set, we can go into more detail, but I just want everyone to be aware of these are all very regulated testing requirements set by ASME and the national board. So in terms of repair and maintenance, so anyone who is able to repair a relief valve, whether it be sanitary or not, has to have a national board stamp for repair and testing. So when Richards went through this process of releasing a relief valve, not only did we have to get the UV stamp for actual manufacturing of these valves, but we had to apply for a separate stamp for an actual valve repair. It is very critical that these valves are not repaired by anyone without a stamp, as it will go against the ASME code. So Richards does have the VR stamp, which stands for valve repair. If you need to change the set pressure, or if you need to replace all the soft goods, it can either come back to Richards or it can go to any VR certified shop. And these are all listed on the National Board website, where you can find these national or these VR stamped shops. And the other stamp to look out for is the TO stamp or TO mark, and that is for testing only. As a very good practice and installation, API lays out how often you should recommend testing your valve. However, it's very unique to every application. Some valves can go years without testing. Some valves need tested every couple months. So it's really up to the customer to determine what works best for their system. But at a minimum, we do recommend testing or popping the valve once a year, just to make sure it's operating correctly. And these can go to any TO certified repair shop or testing facility, and all they're going to do is hook the valve up to air or a liquid and pop it and make sure it's going to pop at the exact pressure that it does. So it's a good way. If you're cleaning your valve regularly with the system, it's going to last a lot longer. If you're not necessarily cleaning it, then it's good to make sure it will pop consistently at the same pressure. We recommend once a year, but as your process dictates, it may be more or it may be less. So with that, I think I took a little longer than I originally expected, so I apologize for that, but please let me know if there are any questions and anything else that I can answer.
So I don't, and Oksana, I don't know if you're still on, but I don't know how to unmute the attendees. Sometimes you're able to do that in this situation. So we do have a question area and a chat area. So if you have any questions at this point, if you can pop them in there, we'll just hang on a minute or so.
The attendees can unmute themselves in the panel individually.
Oh, I see. Thank you. All right. So if anybody has a question, unmute yourself and jump in. I do have a couple questions for you.
Sure.
So you mentioned that specific on the smaller size that there is an O-ring seat option. Is that for food and bev only? Is that non-pharma?
No, that can be for either. So with an O-ring, right, there is the susceptibility for media buildup with that O-ring. So it's for higher pressure applications pretty much only. So that is for anything over, I believe it's 232 PSI, where you need that higher pressure. And so an O-ring is required.
So it's designed such that if you CIP or SIP, it will clean that O-ring area.
Yes, it will. And as long as it fits within the pressure requirements, then yes.
Okay. And my other question was, do you have any actual set points below 15 PSI or is it?
We do have set points below 15 PSI. It's not a standard because it's not in ASME code. However, if you have a set point of below 15 PSI, our engineering team will select a spring set for you and be able to provide that. So the lowest we have gone down to so far is 9 PSI, but that's not saying we cannot do lower. It's just whatever the application requires, so we can work with our engineering team to get you the valve you need.
Gotcha. All right, well, thank you for that. Any questions out there from attendee land? Okay, I don't see any questions in the chat or in questions themselves. So why don't we wrap this thing up? Megan, thanks so much for your presentation.
Yeah, thank you.
Oh, sorry about that. For the attendees of today's webinar, if you have any specific application questions, please feel free to give us a call at 800-9-LESSMAN, L-E-S-M-A-N. If you don't know your account manager, feel free to ask for me, Chris Modrich. I'll make sure you get taken care of. You can also reach me at chrism@lessman.com. If you have interest and would like to learn more about some of the equipment we supply, our past webinars are posted both on our Lessman website and on our Lessman YouTube channel, which is Lessman Instrument Co. And if there are any topics you'd like to hear about in the future, we have access to lots of industry specialists like Megan, and we're always looking to put on webinars to help people learn about process equipment. So let me know, again, chrism@lessman.com. So with all that said, we'll call this the end of this deal. And thanks again to everyone who attended, and to Megan for being our presenter, and Oksana for being our coordinator. And everybody have a fabulous day. Thank you.
Thank you.